So, just real quick, how many of you out there are actually testers? You can raise your hand if you test something primarily. What about developers? Primarily development? Okay. What about not a tester or developer, like a recruiter, for example? All right. I know they're shy about their hands. Okay, great. And what about for techs around here? Who's primarily working in Java these days? This is mostly about JUnit, so otherwise it's going to possibly be boring. But what about Ruby? They're much more assertive with their hands, I noticed. Python? Okay. Great. This talk is mostly about combinatorial testing for Selenium using JUnit and Sauce Labs. As such, it goes into some of the details about writing parameterized tests in JUnit. Myself, I'm with Dynacron Group for the last 2.5 years. Before that, I was mostly a manual tester. About 4 years ago, I was still writing test automation in Perl. So that's kind of funny, seeing someone actually wanted to use Perl. I know, the horns, awesome. And as far as Dynacron Group, what we do is we're not an evil corporation from how you used to be in the future, in spite of our name, in spite of the shark logo, too, which is awesome. It's either that or a chronometer of some kind. We're a Seattle consultancy. We help with integrating testing, continuous delivery, big data strategies, deployment automation, that kind of thing. Mostly what we do is we actually help companies kind of transform their process from old-fashioned style into more of an agile, continuous delivery methodology. So, without much ado, this talk is about a really common problem in Selenium. That's that we have tests that are kind of slow to write, that there are lots of combinations that need to be tested. There are different browsers, versions, operating systems, languages, skins, that sort of thing. And the combination interfaces are all very similar. So we want to write tests we can use over and over and over again in lots of different ways, and we want to do it in a way that's comprehensible and fast. Does that sound familiar to anyone? Some people? Okay. Well, anyway, I'm more of a tinkerer, so what I'm going to talk about isn't really a perfect solution. It's just a solution that we worked through. I'm going to talk about some of the problems we came up with along the way. So I'm anxious to hear other people's ideas as well. Your questions are going to be welcome at the end of this. So I'm going to start by actually switching over and taking a look at the site that we were trying to test. So the start of this problem was that we had a client called IHT, Intercontinental Hotel Group. I'm just going to bring up their site. Perfect. Great. Just taking a look at this site from a testing perspective, across the top we have this nice brand bar. You'll notice also that the brand is in the URL at the top. We have a language selector on the right. The language is also up there in our URL, nice and easy for us to manipulate that from a testing perspective. So our goal was to find a way to write testing flows that would test this across multiple browsers, test this across multiple brands, and test this across multiple languages simultaneously and easily. So as you can see, we switch between different brands. We get, well, that one's very different. A lot of the same interface across the top here. Let's see, Holiday Inn, same reservation. Holiday Inn Express, same reservation system. So, finding a way to test all these different combinations across all these sites at the same time quickly. When we came to them, what they were doing before was they were using Selenium IDE, and they were converting those tests using a custom extension straight into JUnit and just leaving it there and done. Anyone here still use Selenium IDE for all your testing? No hands. Okay. That's what we told them right off the bat, is that Selenium IDE was no good way to do this. So, the trick here is figuring out how to describe these parameters in the first place. So, kind of coming from the top down, how do you describe all the different combinations that one could possibly test? So the way that we were doing initially was using CSV files. You can kind of see that up here. And it was kind of a mix actually of CSV and PSV, I guess pipe separated variables. So it allowed them to get a little bit of detail over the different kinds of parameters that they wanted to run. It's kind of easy for the manual testers to use because CSV is pretty comprehensible. It allows for a little bit of nesting, but the trouble is that it's not really good at containing really complicated data. Like if you wanted to throw in, say, different desired capabilities into this, desired capabilities interface, which can contain nested maps, substrate maps, or maps, if you know what I'm talking about, then the CSV isn't going to really help you with that process unless you're going to keep nesting different layers of separators. It's also difficult to read, and it's kind of ugly. Elegance should be, a goal in any programming. But so the way we moved away from this into a structure that can allow for more nesting was using typesafe config. Have any of you used that library? The typesafe config library. It's used by Gatling. That's where we got introduced to it. Gatling, which is a performance testing tool written in Scala. And I'll show you what the parameter combinations end up looking like there instead. So typesafe config is really nice because instead of describing parameters using a flat file, what we end up using is basically just JSON. And JSON is really useful because it does allow for us to create more complicated structures like arrays or hash maps. And these structures can also map back to objects easily. So in this case, if I want to describe all the different browsers that I want to run this test against Firefox version 16 on Vista, Chrome running the latest version on Vista, then I can create an array and then nested inside that array different hash maps that correspond to the WebDriver configurations. So this gave us a lot more flexibility for describing parameters. And on top of that, the library also is the HOCON library is actually simplified so that it's a more human-readable format. So you don't have a lot of the restrictions that you would normally have with JSON. You'll notice that we don't have to, like, say, appear a colon here. Then that's nice because otherwise it would make it really painful for us to write JSON in a config file. There are lots of little mechanical nuances that one might run into. You also see that with the hash map where you don't have to actually add a comma in between each one of those entries. We don't have to surround them with double quotes. So, the only problem with the solution so far that we run into is that the problem is actually more, as we got deeper and deeper into the application, the problem is actually more complicated than it looks. In that just describing arrays of objects isn't sufficient if your parameters are linked. Once we got into the actual language support for each brand, we get a map that looks kind of like this. And when you're trying to find linkage between these different data values, then you end up with this sort of a graphed problem. If they're not independent, then how do you describe the links between them while still keeping them in that kind of object format? We're still kind of working on a good solution for that. Make sense so far? Sorry, it's super quiet. Yeah?
What's your release cycle?
The release cycle?
Yeah.
Well, this is our client release cycle, so that's the other trick. We were brought in for test automation, so their release cycle is much more slower than we would usually have. So the next problem with this is that if we have all these different brands, browsers, and locales that we're testing against, how many different combinations are we actually going to test? So supposing that we have browsers A, B, C, D, and E, locales 1, 2, 3, 4, brands X, Y, and Z. And we're going to let S1 be the size of the largest parameter array, and S2 be the next largest, et cetera, et cetera, et cetera. So how many of these combinations should we test? What would be like the most, if we were going to provide 100% coverage, how many combinations does that come out to be?
60.
Right here, 60?
I said 60.
60? 5, 4, 3. Right. Fries. Right, 60. Because we're actually going to test every single possible combination, then it's actually, we're multiplying the size of all the different parameter arrays. We have to be testing A1X, A1Y, A1Z, et cetera, up and down the line. So, And in reality, with our client, we have five supported browsers, but we have 9 brands, and we have X number of languages, 11 languages, I think. So once you start blowing that out, you realize that there's possibly we may need to choose which combinations we're going to test, how many combinations, and in some way constrain that. So we came up with 3 different strategies for constraining the number of combinations for a given run. Now the first one is that we test each browser once. Each parameter once, and we consider that sufficient. Oh. So in this case, the number of possible combinations we have to test is only 5. We just need the largest number of parameters, iterate through that, all the rest of them iterate through them, and then loop if we hit the end. Pretty simple. Does anyone see any problems that you could possibly run into with this? What's that? Time? Right?
You're already testing, repeating testing already, so that's not good.
So we are repeating the testing of some parameters. And it does take time to test at least that many combinations, although, yeah.
What happens to brackets that don't support short locales?
What's that?
What happens to brackets that don't support short locales?
Exactly, there's that too. But that's a separate problem. I'll show you the solution that we came up for that. And it's not ideal, but it was good enough to work for now. The nice thing about this is actually that the time is much, much less than it would have taken for all possible combinations. So if we have running all 60 combinations, as compared to this 5, we're taking a 12th of the time. But there's a lot of risk involved in that we don't know if there are any interactions between these parameters. So if there is a problem that arises only between this browser and this locale, we're never going to hit that we don't know if we're going to hit that in testing. Especially if it ends up to be like a third order problem, where it involves all 3 of them, only one possible combination between all 3. So there's risk associated with it. Yeah?
Do you randomize it, or is it the same?
We randomize it.
Okay.
We try to randomize it. Yes.
Based on what? Randomized based on what? You just make, or you look at their analytics, okay, if we choose these pairs, we will cover 99%.
Good question. And that's one thing that I want to follow up with this. Right now it just randomizes. So it's going to pick a random starting point, it's going to loop for each one of those arrays and then loop through. A better solution would be, in the long run, to track which combinations you were actually testing, and see, and basically fill that out into a graph where you can see which combinations have been tested over time. We're not there yet.
Is this the solution you chose, or is this just one possible solution?
It's one possible solution.
Okay.
Yes.
All right.
So next idea is all pairs. Well, we'll make sure that we test at least all pairs of possible browsers, where each browser will be tested with every locale. Each locale will be tested with every brand, but we won't test every single brand locale brand combination. So the number of combinations ends up being the multiplication of the largest and the second largest parameter arrays. We can describe those out here pretty easily. I didn't mean there be an animation on this, which means I have to do a lot of clicking. So there are all 20 possible combinations. The method that we use for this, actually, we have to, you're looping through the second one, and then the second one and the third one, and then you shift the third one up a level each time you do a pass-through. I'd love to make a mathematical proof that this actually provides full coverage, but for now it's been sufficiently tested manually. I was only a math minor. So this obviously has a lot less risk, but a lot more combinations. Already we're up to 20 combinations. Am I going to be able to test this locally ever? No. It's going to kill my computer. The only way I can possibly do it is parallelizing it out through Sauce Labs. But even then, I'm going to be hitting pretty high concurrency. If I have 2 or 3 testers doing it at the same time, 60 concurrent threads, that's a lot of throughput. Now last of all, we could be testing all possible combinations. In which case, as we said, we're actually multiplying out every single parameter, the size of each one of those parameter arrays, in order to find out the total number of combinations. Which, as you mentioned, comes out to 60. And I don't have all 60 listed, so that's that. I am sure. So, what is finally, so how can we describe what the risk is that we involve if we use each once instead of all possible pairs? So if we have the probability that a given pair